The YouTube algorithm works in strange ways. I recently did a video about cassette tapes, which plenty of people my age who grew up in the 80s and 90s would have memories of and experience with, but it turns out the largest group of people watching that video were senior citizens. Then I did a video about records which are over 100 years old, which virtually no human beings on Earth are old enough to have memories of when these things were new. But yet plenty of people in their 20s and 30s watched that video. So since young people seem to like really old stuff, this little thing definitely caught my eye when I saw it in a thrift store recently. It is a circuit tester measuring ohms. And it definitely looks very, very old. It's a rather worn metal case with two screws on top for attaching the terminals. There's a little adjustment up there for zeroing the meter. On the back, the original owner scratched in his name, Tom Woods. This is something that people did a lot before label makers were invented. And it comes with directions on another metal plate attached to the metal case. So this thing is entirely metal, and this faceplate for the meter is definitely glass. So there's probably not a single piece of plastic in this entire thing. I thought this would have been made of Bethlehem steel, but it turns out it's not magnetic. So I think this entire thing is painted brass. You can see it showing through there where the paint has worn away. Directions: connect instrument directly to circuit, no external battery required. Needle should point to 0 when posts are short-circuited. As battery weakens, short-circuit posts and bring pointer to 0 by turning screw located between posts. To renew cell, unscrew instruction plate, insert new cell and adjust to 0. And it was made by Roller Smith in Bethlehem, Pennsylvania. This one has a range of 0 to 10,000 ohms, and then the end of the scale is infinite. And I love that needle on the meter. The movement is nice and free. It says don't use for testing blasting caps or blasting circuits, because obviously this thing puts some voltage across whatever you're testing, so you don't want to put that across an explosive device, otherwise it may ignite. In fact, they can even sometimes ignite by radio signals. I haven't seen them in a long time, but I remember seeing signs along the road saying not to use your two-way radio, like a CB radio or ham radio, because they were doing blasting in the area. I tried to find the history of the Roller Smith Company. They were based in New York City, and they had their factory in Bethlehem, Pennsylvania. It seems like their heyday was back in the 1920s and 1930s, because that's when most of the information I can find about them is from. This ad is from 1932, and it's announcing their Type HTD2 circuit tester and ohm meter, which is very similar to the one I have, except it's larger and has a switchable low and high range. They say it runs on a renewable standard flashlight cell, with flashlight spelled as 2 words. They say the circuit tester is the most useful instrument that can be imagined, and any and everyone who has occasion to test circuits for continuity and resistance should have one. They don't mention the price, but they say the price is surprisingly low. Roller Smith products comprise complete lines of electrical instruments, indicating and graphic, relays, air and oil circuit breakers, and control panels. Hopefully nobody left old batteries in this, so I'm going to unscrew this direction plate and see what's inside. Although I'm actually hoping there's some kind of vintage battery in this that would be very interesting to look at. Because often those old batteries don't actually leak that much. They just kind of silently go dead. Okay, there's the screws removed. There's the instruction plate. And inside there's nothing. So thank you, Tom Woods, for removing the battery the last time you used this. So it looks like that would fit a C-cell battery, but I want to see more of that meter, so I'm going to take off the rest of the faceplate. I removed the screws, so now here is the reveal. That comes off with the glass attached to it. And that definitely is a piece of glass. And not a whole lot more that we can see, but we can see the meter movement. Oh, there it is, type HTD. So the ad was for the HTD2. So if this is the original HTD, that means it's even older than 1932. Unless they continue selling it alongside the HTD2. Number 544164. Made in USA, of course. NP 2186. I'm not going to take this meter apart because I don't want to mess up the calibration, but definitely a nice vintage meter. And no corrosion on the battery terminals. Maybe a little bit of green stuff on the negative, but nice and clean brass terminals. That one has a plus mark on it. So I'm going to put in a new C-cell battery. Here's a C-cell battery made by Rayovac. It was made in the USA. They're another company that's been around for a long time. So let's see, is this going to fit? So the battery is installed. Now let's put it back together and see if it works. I just attached some clip leads, nothing fancy. So let's see if it works. Aha, it does. I like that movement of that meter. The way it bounces around, that's nice. Now let's zero that meter setting. Now I'm going to follow the instructions to short circuit the leads and adjust the trimmer on top until it reads 0. Well, doesn't seem to make much difference. Oh, it's going down a little bit. That battery I put in wasn't the strongest, so that may be why it's not reading all the way to 0. So let me get a brand new battery in there and see if that makes a difference. A new battery has been installed, and shh, don't tell anyone it's actually a AA cell wedged in there because I don't have any good C cells left. And now if I short circuit the terminals, it's actually going off the end of the scale, so I have to turn down the rheostat until it reads 0 on the meter. There it goes. Right about there. Now I have some resistors to test measuring. I'll start with a 100 ohm resistor. And it's showing about 95 ohms. And that is a 5% tolerance resistor. So that is in tolerance. Even on this 90-plus-year-old meter. So that's good. Here is a 380 ohm resistor. And that's reading, let's see, that's 200, 300, 400. So that's perfect. Right on the money there. 380 ohms. Next is a 1K resistor. And again, right on the money. 1,000 ohms. Now the scale is getting more bunched up as I go higher in value, so it's going to get a little less accurate and more difficult to read, but that's just the way these meters were. This is a 4.7K resistor, and it's pointing right at 5,000, so within the tolerance of that little bit of range, that's pretty good. And finally, this is going to be right at the end of the scale, a 10K resistor. The meter should just barely move. Oops. Oh, did I thought that was 10K. It's actually another 1K resistor. My bad. Well, the meter showed me. Okay, this should be a 10K resistor. Brown, black, orange. and then gold for 5% tolerance. So put that into the terminals, and yeah, it just barely moves, pointing at pretty much right on the 10,000 mark. So this 90 or more year old meter is working perfectly. Now here's a 5K potentiometer. So if I measure across the whole thing, it should read 5K, as it pretty much does. And if I attach it like this, we should get a range of motion on the meter as I adjust it. Turn it up, and the resistance increases. Here's a 1K potentiometer. So across the whole thing, we get 1K, and now we get our range of motion up to 1K. You can even see it's scratchy. It makes the meter bounce a little bit. Yeah, this pot hasn't been used in a while. That's why it's bouncing around, because it's a scratchy pot. And here's an oddity. A 10 ohm potentiometer. It's probably the lowest value potentiometer you'll ever see. So if I connect that, yep, 10 ohms. And for what it's worth, we should get motion between 10 and 0. Again, a scratchy pot. So that's all you get from 0 to 10 ohms. Here's a 500 ohm impedance dynamic microphone, and when I measure across it, we get 450 ohms. So that's pretty close. And here is a 4 ohm impedance speaker, and measuring it, it's showing exactly 4 ohms on the meter. Now I have it connected across a small DC motor, and as I twist the motor, you can see the needle swings. So that's interesting. Oh, and if I rotated the opposite way, you can see the meter moves to the left, and this way it moves to the right. So this has been a look at and test of the Roller Smith HTD circuit tester and ohm meter, probably from the 1930s. So it's around 90 years old and still working perfectly.